To understand why different solid phases can have phase transformation, we have to introduce a concept called Gibbs free energy. We'll do that step by step and start by discussing a concept called internal energy, denoted by E. Assume we have two solid phases, A and B, and if the internal energy of A is greater than B, the question is, will phase A spontaneously transform to phase B? Intuitively, you may say the answer is yes, because by doing the phase transformation, you lower the overall internal energy. However, the concept of internal energy does not capture the entire picture. The correct answer to this question is we don't know, because there are other factors we have to consider. For example, the external load or pressure can affect phase transformation. To account for that, we'll introduce the second term called enthalpy, denoted by the letter H. Enthalpy is defined as E plus PV, where E is the internal energy, P is the pressure, V is the volume. For the simplicity for our analysis, let's for now turn a blind eye to the effect of PV. Subsequently, we'll have HA greater than HB. Again, H itself does not capture the entire picture. Phase A having higher enthalpy does not guarantee the phase transformation from phase A to phase B. To really determine whether phase transformation will happen, we need to introduce the third concept called Gibbs free energy. Gibbs free energy is defined as H minus St, where H is the enthalpy, T is the absolute temperature, S is entropy. Entropy is a measure for randomness. You may have learned the concept of entropy in thermodynamics class, and you have learned the overall entropy is always increasing in our universe. Now, equipped with the concept of Gibbs free energy, we can predict whether phase transformation will happen. If the Gibbs free energy of phase A is greater than the Gibbs free energy of phase B, then phase transformation will spontaneously take place. Let's take one more look at why the internal energy or enthalpy alone cannot predict whether phase transformation will take place or not. Let's look at two scenarios. In the first case, the internal energy or enthalpy of phase A is larger than that of phase B, but it's only slightly larger. Meanwhile, phase A has much higher entropy than phase B at a given T. Under these conditions, phase transformation will not occur. And we say the effect of entropy is dominant. In fact, nowadays, there are so many researchers doing studies on a new class of metals called high entropy alloys. The idea of high entropy alloys is to increase the randomness, to decrease the Gibbs free energy, and to stabilize the desired phase. In the second case, again, we have the enthalpy or internal energy of A that is greater than B. And in this case, the enthalpy of A is much greater than that of B. Meanwhile, the effect of entropy is insignificant. In this case, the enthalpy effect will prevail and the phase transformation from A to B will take place. Taken together, whether phase transformation will happen or not depends on the Gibbs free energy, and it is not solely dependent on the internal energy or entropy. After understanding the concept of Gibbs free energy, we can introduce our next concept called equilibrium. Equilibrium is defined that in a system, dg, the change of Gibbs free energy, is equal to 0. Note that dg equals to 0 is not necessarily that g is at the minimum. Let's use a graph to illustrate what equilibrium is. On the x-axis, that's the arrangement of atoms, and on the y-axis, that's the Gibbs free energy. There are two energy wells here. One is on the left and one is on the right. The one on the left is not the lowest energy state. Therefore, this equilibrium is called metastable. For example, carbon can exist in two equilibrium phases. One is diamond and the other is graphite. The diamond phase is actually metastable. Therefore, the diamond is always slowly phase transforming into graphite. You may have heard diamond is forever, but thermodynamically, graphite is forever. In the future, if you plan to propose, you may consider a graphite ring to represent your internal love. In the next video, we will have a closer look at the Gibbs free energy and discuss the effect of temperature and pressure on Gibbs free energy.